Welcome back. Today we're going to start antiderivatives, which is basically what we work on all of second semester. First semester was derivatives. Second semester is antiderivatives. Go figure. So we're going to start with the power rule in reverse. And it's really easy, don't stress. Okay, so if this is the derivative equation, just guess and check and try to figure out what would the original function be. So hopefully, if you just think about it for a while or keep practicing and trying things, you know if this is an x to the first, then the original function has to be an x squared of some sort, right? So maybe you're thinking, if I had x squared, would that work? Is the derivative of x squared 2x? Sure. Well, how about this though? Could I also have this? Would the derivative of this also be 2x? Yep. How about this? Now would the derivative still be 2x? Yup. So what we say is, well, right, that the antiderivative is x squared plus c. And c stands for constant. Any constant could go there. And you won't know exactly what constant goes there unless they give you more information, like giving you a point on the graph. Okay? So now, how do we do that? How do we get this? Well, to find an antiderivative with the power rule, what you do is the opposite of what we did for derivatives. For derivatives, we took the exponent and we multiplied and subtracted 1. Well, we're going to do the opposite in the reverse order. Instead of multiplying and subtracting 1, we're going to add 1 and divide. So let's go back over here. Using the power rule, this is currently a 2x to the first. We're going to add 1 to the exponent and divide by that result. And that's why it's x squared. Okay? You get used to it. It doesn't take long. Let's try another one. Well, this one's too easy. You could do that one in your head. The antiderivative would just be 5x plus c. All right, let's do the next one. All right, we're going to do our power rule. Add 1 to the exponent, which make that a 3, and divide by that number. Okay? This one, add 1 to the x to the first, and you'd get x squared, and divide by that result. Here, that's just going to be 4x plus c. So f of x would be this, and obviously these 3's cancel. And you could write this as x squared over 2 or 1/2 x squared. Okay, warming up. Let's do it again. Okay, this one, why don't you write it down on your paper? Make sure you change this square root to a 1/2 power. You write it down, hit pause, and see if you can do it on your own. Okay, let's see how you did. Add 1 to the 4, and that'll give you a 5. And divide by 5. So that's going to be 2/5 x to the 5th. Add 1 here, you'll get a 3, and divide by 3. So that's going to be negative 5/3 x to the 3rd. Change the square root to a 1/2 power. Add 1 to it, and when you add 1, think 2 over 2. Okay, so that's going to be a 3/2. So I have 6 x to the 3/2 divided by 3/2. Now, when you divide that, remember you're going to multiply by the reciprocal. So in your head or off to the side, that's really 6 times 2/3 for that coefficient. The 6 and the 3 cancel, and you just get 4. So we have 4x to the 1/2 plus 2/2, which is 3/2. And then this one, this is currently x to the 0. Add 1, and you get 4x. Don't forget, plus c, because again, any constant would work. Nice thing you can do though, nice thing about antiderivatives is you can always check them. Work it in reverse, do the derivative, and you should get the original problem back. Okay, so that's pretty much all we're going to do. Let's just try it again. All right, this symbol is an integral, and when we say integrate, that means find the antiderivative, okay? They will always write dx at the end because we're integrating with respect to x, but you don't really do anything with that, so don't stress about it. Just do the antiderivative power rule the same way you just did the last problem, but you're going to have to move this up. Now, I want you to go ahead, seriously, hit pause, write this problem down and try it on your own, because there is something I need you to see about this one. I'm trying to trick you on something, okay? So hit pause. So the first thing you should do is rewrite it so that you can do the power rule, okay? And I have a little glitch in this one for a reason. I'm trying to make a point. So hopefully you figured out that you got stuck on something. All right. Then we do our power rule. Add 1, and this turns into a 3, and divide by 3. So I have 2x cubed. Add 1 and divide by that same answer, and we get x squared. Add 1, you get negative 1, and divide by negative 1. So it's going to be a 5x to the negative 1, which hopefully you know we're going to move that to the bottom and turn it into 5 over x. Okay, this last term is where the issue is, okay? This one, I want you to see what happens when you don't realize what you started with. If I do the same rule here and I add 1, I get 0, and then I try to divide by 0, and you can't do that. So this is actually not a power rule. This guy is special. So I have to remind, and this, I wanted you to see that if you get divide by 0, you're supposed to go, oh, this isn't one of those. And here's what it really is. Going back to derivatives, the derivative of the natural log of x is 1 over x. So when we work it in reverse, the integral of 1 over x is the natural log of x. So we're working it backwards. So this one is, it looks just like the previous term, right? It looks just like, well, I can't get it. Here we go. All right. This looks just like this guy. They don't look much different, but it is because it's an x to the first, so that's natural log. It's not a power rule. So that last one, if you think ahead, if you see an x to the first on the bottom, you're not going to rewrite that one as an exponent. You just have to know that that's natural log. So this is 3 natural log of x plus c. Okay? Now, there's another glitch you may or may not remember, but you can't take the natural log of a negative number. So anytime you write your natural log as an answer, you're going to put absolute values around what's behind it right there. Okay? All right, so maybe rewind and watch that again, but it's all based on this. The derivative of the natural log of x is 1 over x. So when you work it in reverse, you got to recognize anytime you get this dividing by 0 thingy, oh, that was really a natural log problem. Okay, so now let's look at all the other ones. All right, these were our derivative rules, and we're working them in reverse now. So we already discussed this one. This one, if you see secant squared, that's one that comes up pretty often. The integral of secant squared is tangent. Just work it backwards. Okay? Now, these guys. If before, when we did derivatives, when we wrote sine as our answer, we changed the sign. Now it's going to be in reverse. So now when you integrate, it's cosine that's going to be negative. So now the integral of cosine is just sine, but the integral of sine is negative cosine. So it's the opposite of what it used to be, okay? Now, e to the x, the integral of e to the x is still e to the x. Okay, there's going to be more to it. There's a little bit more when we do more tomorrow, you'll see. Okay, and then here's the tricky one. If the derivative, I got to go derivatives and antiderivatives at the same time. If the derivative of 3 to the x is 3 to the x times the natural log of 3, then what do you think the integral of 3 to the x would be? It's 3 to the x divided by the natural log of 3. Plus c. All of these are plus c's. I forgot my plus c's. Okay? So, study your integrals. And if you look at the cover of your book, there's a list of all of them. It's just the basics today. Okay? We're not going to make it too tricky. I'm going to give you a worksheet so that is just these basics. Please memorize your basic derivatives. And therefore, your antiderivatives, all these basic ones that you already know, memorize them. Make sure you really have them in your brain before you do today's assignment. And then try to do today's worksheet like it's a little quiz of your memory. Okay? Good luck, everybody. Hope you're doing well. Bye. Oh, wait, before I go. we will be doing this for a few days. It's just like when we did derivatives. You got to like train yourself to memorize it and get used to it. So hopefully it's not too much of a struggle the first day, but it gets easier and easier with each day. All right. See ya. Bye.